Hello, everyone. Welcome to the Math Magician's Den. This is the Herm Dog, and we are going to talk right now about critical numbers. What is a critical number? Well, first of all, a critical number has to be a spot where my function is defined. So if we say x equals c, there has to be a point there at x equals c. The other thing is this: the derivative at c has to be equal to 0, or the derivative at c has to be undefined. Those are spots where we have critical numbers. This right here at x equals 1 is a critical number. The coordinate 1, 0 is called a critical point. Why? Because the derivative at 1 there, because I see a cusp, the derivative is undefined. That's a critical number. X equals 1, the point 1, 0 is a critical point. Same thing in the next picture. At x equals 1, I have a critical number. At the point 1, 0, at that corner, I have a critical point. Why? Because the derivative at 1, again, is undefined. The third picture, at x equals 1, we have a critical number. The point 1, 0 is a critical point. Why? Because the derivative at 1 is equal to 0. I actually have a horizontal tangent line there. And in the next picture, I actually have two horizontal tangent lines at x equals -2 and at x equals 2. I have two critical numbers in this picture. Why? Because f prime at -2 equals 0 and f prime at 2 equals 0. So I have two critical numbers, 2 and -2. I have two critical points, -2, 4 and 2, -4. Now what I want you guys to notice also here is that even though I have critical numbers, I may not have max or minimums. This one right here is a minimum. This is a minimum. This is a maximum and a minimum. So it looks like critical numbers give me maximums or minimums. But here we figure out not always. If your function has a relative maximum or a relative minimum, that value at x has to be a critical number. Now, if it's a critical number, that doesn't mean it's going to be a maximum or minimum. So here's what we're going to do. And today we're going to talk about just specifically absolute maxes and minimums. So when I say extrema, I mean absolute maximums or minimums. Now, we talked about this. You can find absolute maximums or minimum at relative maximums or minimums. So here's where we're going to find the critical numbers. But also you could find absolute maximums or absolute minimums at endpoints. So we're going to look at the critical numbers of my function. We're going to find those. Okay? We are going to evaluate the function at those critical numbers, and we're going to evaluate the function at those endpoints. The least value is going to be your absolute minimum. The greatest value we find is going to be your absolute maximum. And I want to show you how this is done. Okay? We're going to take a graph here. The graph is 3x to the fourth minus 3x cubed. Okay? First thing I'm going to do is I'm going to find the derivative. The derivative is 12x cubed minus 12x squared. Okay? Now the first step says find the critical numbers. Well, to do that, I have to set my derivative equal to 0. I'm going to factor out a 12x squared. I'd be left with x minus 1. Here I would get x equals 0, and here I would get x equals 1. These are your critical numbers. Now here's what we're going to do. We're going to plug those two numbers back into my original function. But I am also going to plug back in the endpoints. I'm going to plug in -1 and I'm going to plug in 2. Because we said that absolute maxes and mins could be at the endpoints, or they could be at the relative maxes and mins, which could be at critical numbers. So what is f of -1? Well, -1 to the fourth is 1 times 3, that would be 3, minus 4 times -1 cubed would be -1 times -4 would be plus 4. This comes out to be 7. At -1, the value is at 7. If I plug in 0, that's easy. It gives me 0. If I plug in 1, I would get 3 minus 4, which is negative 1. And if I plug in 2, this is going to be a little bit harder for me to do. If I plug in 2, this is 3 times 2 squared, or 2 to the 4th, which is 16, minus 4 times 2 cubed, which is 8. So I have 48 minus 32. This comes out to be 16, which I didn't do a real good job on the graph. At 2, we're way up here at 16. So this graph comes down. If you graph this on your calculator, it would level off here, it would come down here, and that would shoot all the way up to 16. Now, really, we don't even need to know that about my graph. I don't need to know what the graph looks like. All I have to do is take a look at the values I just found. 7, 0, negative 1, 16. Which one of those is the smallest value? Negative 1. Okay? So my absolute minimum, the minimum value is negative 1. It is found at the coordinate 1, negative 1. What's the highest value out of all 4 of these? That would be my absolute maximum. My absolute maximum is 16. It's located at x equals 2, so the coordinate is 2, 16. This is how you can find absolute maximums and absolute minimums. Now, each one of these problems I've given you here is a little bit different. G prime of x, the derivative would be 2. Bring the 2/3 out front, this would be minus 2x to the negative 1/3. I get 2 minus 2 over x to the 1/3. And here's what I tell my students is important about the derivative. Make sure you write it as one fraction. So if I did common denominators, this would be 2x to the 1/3 minus 2 over x to the 1/3. Now what we do with our derivative is I set the top equal to 0. We're going to set the derivative equal to 0. And if you were to solve that top part of the equation equal to 0, you would get x equals 0. That's a critical number. But ladies and gentlemen, that's where the derivative g prime of x equals 0. If you set the bottom equal to 0, this is not where the derivative equals 0. This is where the derivative is undefined. And I get x equals 0 there. And sorry, I apologize, in the red, I should have written x equals 1. When I set the top equal to 0, I get x equals 1. When I set the bottom equal to 0, I get x equals 0. They're both critical numbers. But when you set the top equal to 0, you get a spot where the derivative equals 0. When you set the bottom equal to 0, you get a spot where the derivative is undefined. And again, what I've got to do is I've got to take my function g of x and evaluate it at negative 1, and I've got to evaluate it at 3. I also have to evaluate it at my critical numbers. So I need to know g of 0, and I need to know g of 1. Now, g of negative 1, if I plug in negative 1 here into my original function, I would get negative 2 minus 3, that would be negative 5. At negative 1, the value is at negative 5. If I plug in 3, I'm going to have to use my calculator on this because I don't want to take 3 to the 2/3. So I'm going to take 2 times 3 minus 3 times 2, 3 times 3 raised to the 2/3. And I get negative 0.240. Now, if I plug in my critical numbers, so if I plug in 0, I'm going to get 0. If I plug in 1, I'm going to get negative 1. So at 0, I get 0. At 1, I get negative 1. And then, like I said, at 2, at 3, I get negative 0.24. So this graph comes up, hits a cusp, comes back down, and comes back up to here. And again, I really don't need to know what the graph looks like. Here's what I need. I need to know what the lowest value out of all of these is. The lowest value is negative 5. The absolute minimum on this graph between negative 1 and 3 is negative 1, negative 5. The absolute maximum is the biggest value you see. That's 0, 0. So the absolute maximum value is 0, and it's found at x equals 0. This is how we do our absolute maximums and minimums. Now the next one with trig, this one's really going to create some fun for us. I am going to basically take the derivative here, and I'm going to get h prime equals 2 cosine of x. The derivative of cosine is negative sine of 2x, and the chain rule says I have to multiply by 2. Now I'm supposed to set this equal to 0, which would be hard to do if I don't have a calculator. So what we're going to do is we're going to do a little bit of trigonometry here. Sine of 2x, that's a double angle formula. That's 2 sine of x cosine of x. So I'm going to plug that in right here, and I'm going to get plus 4 sine of x cosine of x. And I got to set that equal to 0. Now, how do I solve a function like that? Well, I'm going to factor out the 2 cosine of x, and I'll be left with 1 plus 2 sine of x. If you set this first factor equal to 0, cosine of x equals 0 at pi over 2 and 3 pi over 2. Those are my critical numbers. Here, I would get sine of x equals negative 1/2. Where does sine of x equal negative 1/2? Well, where's sine negative? Sine is negative in the third and the fourth quadrants. So sine equals 1/2 at the multiples of pi over 6. So we're talking 7 pi over 6 and 11 pi over 6. And this is what really is going to be difficult about this problem. I have to evaluate h of x at 0 and at 2 pi. And I've got to evaluate it at all of these critical numbers. I've got to find h of pi over 2, and in order, h of 7 pi over 6, h of 3 pi over 2, and h of 11 pi over 6. Okay? So this gets very difficult if I want to try and do these problems without using a calculator. I'm going to have to use my unit circle. Okay? And in order to use my unit circle, I've got to remember the values at the pi over 6s and the pi over 2s. Well, if I plug in 0, I'm going to get negative 1. If I plug in pi over 2, I'm going to get 3. And what I'm doing is, pi over 2 is about right here at 1.5. It's at 3. If I plug in 7 pi divided by 6, I get negative 3/2. Okay? And that's at about 3.66, negative 1.5, right about there. If I plug in 3 pi over 2, and you guys can try this on your own, you're going to get negative 1 again. 3 pi over 2 is at about 4.7. If I plug in 11 pi over 6, I get negative 3/2 again. And that's at about 5.7, negative 1.5. And 2 pi, I'm right back to negative 1. And 2 pi is at about 6.28, right there at negative 1. So this graph goes up, it comes down, it goes back up, it goes back down, and back up. Now, I figured out these values ahead of time, but here's the thing. What is the biggest value that you see in this entire list? Right here. This is my absolute maximum. Where is my absolute minimum? Well, my absolute minimum, there's actually 2 of them. There's one here and there's one here. Both of those are absolute minimums. You can have more than one absolute minimum. This one has 2 on this interval. I hope this helps in explaining how to find absolute maxes and minimums. You can find them at the relative maximums and minimums, which involves finding critical numbers, which involves finding the derivative. But don't forget to check those endpoints. The highest y values on the original function are your max. The lowest y values are your min. If you like this video, please like and subscribe. I appreciate you guys watching the video, and I hope it helps. I'll be posting more videos soon.